Hello dear students, myself Dipali Jain and I am working as an assistant professor in Tekeva College of Pharmacy, Nashik. Today we study about thermal methods of analysis. So let us start with the definition of thermal analysis. So what is meant by thermal analysis? It is the branch of material science where the property of materials are studied as they change with temperature. When matter is heated, it undergoes certain physical and chemical changes. Okay. So definition of thermal analysis is it is the branch of science or material science which deals with the study of physical and chemical changes occurs when we apply the heat. Okay. So there is some physical and chemical changes produced. So physical changes such as melting, vaporization, crystallization, transition between crystal structures, changes in microstructure in metal alloys and polymers. Then it also includes volume changes such as expansion and contraction and changes in mechanical behavior. Okay, so these are physical changes. And chemical changes include oxidation reaction, corrosion, decomposition, dehydration, chemisorption and another. Okay. So these are the physical and chemical changes which occur in the material when we apply the heat or when we varying the temperature. Okay. So these physical and chemical changes take place over a wide temperature range. It is necessary to characterize materials and their behavior over a range of temperature to determine what materials are suitable for specific uses, and we also determine what temperature range materials or chemicals can be withstand without changing. Okay, so here this method thermal analysis we are used to determine the list of materials which are stable at a different temperature. So there are number of types are available for this thermal method. Let us see the types. First one is thermogravimetric analysis. It is also known as TGA. Next one is the differential thermal analysis. It is also known as DTA method. Next one is differential scanning colorimetry or DSC. Next one is thermometric titration or TT. Next one is dynamic mechanical analysis or also known as DMA. And next one is thermomechanical analysis also known as TMA. So these are the types of thermal analysis method. Okay. So let us see the first method. Prior that, firstly we see the designation of methods or types of method and what are the property way they will measure and which apparatus they require. Okay, so in first method, that is thermogravimetric analysis, in this method we measure the change in weight of the material and for that purpose we require thermobalance. Next method is derivative thermogravimetric analysis or also known as DTG. In this method, we determine the rate of exchange of weight. Okay, and for this purpose, we also require thermobalance. Third step is or third method is differential thermal analysis DTA. Here, in this method, we studied or we measured a heat evolved or absorbed by the material, and for this method, we required DTA apparatus. And next method is thermometric titration. In this method, we determine the change of temperature, and for this purpose, we require titration colorimeter. Okay, so this table involve the types of method, then which property we measure by using different methods, and which apparatus we are use. Okay. Now let us see the first method, that is thermogravimetric analysis. So what is the principle behind this method? TGA measure the amount and the rate of weight change of a material with respect to temperature or time in controlled environments. Okay. The change in the weight of the substance is recorded as a function of temperature or time. So what is the principle behind this TGA method? It is the method which is used to measure the amount and the rate of weight change of material when we apply the temperature or when we apply the heat, here some changes occur in the weight, and that weight change we will measure by using this method. So the temperature is increased at a constant rate for a known initial weight of the substance, and the changes in a weights are recorded as a function of temperature at different time interval. Okay, so when we apply the temperature or when we apply the different range of temperature, here some changes occur in the material, and that changes we will measure by using this method. This plot of weight change against temperature is called thermometric curve or thermogram. So students, when we use this TGA method, here we produce the thermogram or graph which is known as thermogram. So on x-axis we denote by the temperature, and on y-axis it is mentioned by the weight change. Okay. So this plotting of graph is known as thermogram. So here is also subtypes are available for the TGA method. First one is dynamic TGA. The sample is subjected to conditions of the continuous increasing temperature, usually linear with time. And second subtype is isothermal or static TGA. The sample is maintained at a constant temperature for a period of time during which any changes in weight are noted. Okay, so these are two subtypes of TGA method. Okay, now next is, this is the example in which we observe the TGA curve for silver nitrate. Okay, so here you can see the graph is mentioned as a temperature versus weight loss. Okay, the horizontal portion of the curve indicates that there is no change in weight, that is AB and CD. In this graph you can see when we apply the temperature from 100 degree to 400 degrees Celsius, here you can see there is no change occur, means in A to B range there is no change of weight. Okay, up to 400 degrees Celsius. So the portion of BC indicates that there is weight change. But when we increase the temperature from 400 to 500 degrees Celsius, you can see there is the change occur. Okay, means this B to C point or BC indicates there is the change of weight loss. Okay, so the weight of the substance, for example silver nitrate, remains constant up to a temperature of 473 degrees Celsius, indicating that silver nitrate is thermally stable up to a temperature. At this temperature, it starts losing its weight, and this indicates that the decomposition starts at this temperature. Okay, so here from A to B, this is the constant up to 473 degrees Celsius. Then there is some weight loss occurs when we apply the increasing the heat, okay, or we increasing the temperature. After that, from 500 degrees Celsius to 800 degrees Celsius, you can see C to D point, there is the again linear linear range is produced or constant line is present. Okay, so in this graph you can see there is the decomposition of the silver nitrate is occur. Okay, so it decomposes to nitrate, then oxygen and silver. Okay, so this is the diagram which indicate the TGA curve for silver nitrate. Okay, decomposition occur into the silver plus nitrate plus oxygen. So this is the example of silver nitrate TGA curve. Now next point is the instrumentation of TGA method. So which type of instrument we require? The principle of TGA are based on the fact that the sample be continuously weighed as it is heated to elevated temperature. Okay, previously we seen the principle. Okay, means we require the instrument in such a way that we can measure the weight loss and also elevated temperature. An instrument which is used for this purpose is called a thermobalance, which consists of the following component. Okay, so for this purpose or in this method we required a instrument in which we measure weight loss as well as elevated temperature. Hence, in this method we use thermobalance as an instrument in which following components are present. First one is recording balance or also known as thermobalance. Then second one is a furnace and furnace controller. Next one is purge gas system. Then sample holder and a recording devices. Okay, so these are the different compartments which are present in the instrument. Okay, now let us see the one by one of these compartments. So this is the block diagram for TGA instrument. Here you can see this is the furnace. Okay, then this is the sample holder in which we place the sample. This sample holder is connected with the recording balance, temperature sensor and recorder. Okay, and in this furnace there is the furnace temperature programmer, flow regulator, atmosphere controller. Okay, so these systems are connected with the furnace. In this furnace and sample holder, between these two compartment, purge gas system is present. Okay, so in this, okay, so this is the block diagram of TGA method. Modern TGA equipment has a sensitive balance, usually a microbalance, for a continuously measuring sample weight, a furnace surrounding a sample holder, and a purge gas system for providing inert or reactive atmosphere. A computer generally controls the furnace and the data, means weight versus sample temperature, is collected and processed by a computer. Okay, so here you can see this is the furnace and in which sample holder is present. Okay, and between the furnace and sample holder we apply the or supply the purge gas system. Okay, for the atmosphere control. Several modern analytical microbalances are commercially available, such as torsion balances, spring balances, and electrobalances. In general, the balance is designed so that a change in a sample weight generates an electrical signal proportional to the weight change. The electrical signal is transformed into weight or weight loss by the data processing system and plotted on the y-axis of the thermal curve. Okay, as we previously seen, we can plot the graph as a temperature versus weight loss. Okay, temperature versus weight change. So when we apply the temperature to that material, okay, there is some electrical signals are obtained which mention the weight loss. Okay, and these signals are collected into the data processing system and then we obtain this thermal curve. Okay, TGA balances are available for sample masses from 1 to 1000 mg with the usual sample weighing between 5 and 20 mg. There are specialized high capacity TGA systems available that can accommodate sample of up to 100 gram. The balance itself must be thermally isolated from the furnace, although the sample holder and sample must be in the furnace. Okay, so in this method we can use the thermobalance which have a capacity of sample up to 1 to 1000 mg. There are two possible configuration of the balance and furnace, a horizontal furnace and or vertical furnace. Okay, both types of configuration suffer from drift as the temperature increase. The vertical configuration suffer from buoyancy effects due to the change in gas density with temperature. The horizontal configuration was designed to minimize the buoyancy effects, but horizontal configuration experience changes in the length of the coarse rod connecting the sample to the balance as the temperature changes. So buoyancy effects and changes in the coarse rod result in error in determining the mass of the sample. Buoyancy effect, it is an upward force which is exerted by a fluid that opposes the weight of an immersed object. Then second compartment is the furnace, which is used to provide the temperature. Okay, so the furnace surrounds the sample and sample holder. It must be capable of being programmed for a linear heating rate. Modern instruments can be heated and cooled rapidly. These instruments that heat at rates up to 1000 degrees Celsius per minute are available. Commercial instruments can heat at rates up to 200 degrees Celsius per minute from room temperature to about 1200 degrees Celsius. Cooling by forced air can be done at 50 degrees Celsius per minute. There are furnaces available with upper temperatures of 1500 degrees Celsius, 1700 degrees Celsius, or 2400 degrees Celsius. These higher temperature instruments are useful for studying refractory materials and engineering materials. Now next part is purge gas system. The furnace must be able to be purged with the desired gas to provide the correct atmosphere for the experiment and to remove gaseous products from the sample compartment. So this is the main use or main purpose of the purge gas system. Argon or nitrogen is used when an inert atmosphere is desired. Air is often used for oxidation and combustion studies. Hydrogen gas may be used to provide a reducing atmosphere with the appropriate precautions to prevent explosions. Modern instruments permit the purge gas to be switched automatically so that the sample can start heating in an inert atmosphere and it will be switched to air or other reactive gas at higher temperatures. Next part is the sample holder. The sample holder and any instrument parts inside the furnace such as the thermocouple for measuring the temperature. It must be able to withstand high temperature and it should be inert at these high temperatures. So for the sample holder, the material are quartz, platinum and various ceramics are used. Okay. The sample is placed in a small pan or crucible which is made up of platinum, quartz or ceramic. Ideally, the temperature recorded is the exact temperature of the sample. So there is number of types are available for a sample holder such as shallow pans, then deep crucibles, loosely covered crucibles and retort cups. So these are the types of sample holders which are used in the TGA instrument. So this is the one technique in which we record the thermogram. Okay, so here you can see this is the sample holder, this is the coil. This is the example or TGA curve of polystyrene where weight, percentage weight and weight loss in mg we can see. Okay, this is the sample holder, this is the coil. Coil is heated, turns red, thermal degradation of sample and sample pan decreases in weight and moves towards. So this is the diagram of thermobalance which is used for the TGA method. So here is the sample holder in which sample is placed. This is the inlet for purge gas and outlet for the removal of unwanted gaseous product. It is covered with the furnace to provide the heat and this sample holder is attached with the thermocouple, okay, which record the changes of weight loss and temperature. This is the modern instrument which is available in the market and number of different types of instrument are available. The thermocouple, it is never inserted directly into the sample because of possible sample contamination or contamination of the thermocouple resulting in an error in a temperature. The temperature actually recorded may be slightly different from the sample temperature. The sample temperature generally it is lower than the temperature recorded by the thermocouple. This is due to the factors such as rate of heating, gas flow, thermal conductivity of the sample and the sample holder. The problem is compounded by the fact that at temperatures below 500 degrees Celsius, most of the heat transferred from the furnace to the sample take place by convection and conduction. but at a temperature which are above 500 degrees Celsius, where the furnace is red hot and most of the energy is transferred by the radiation. The switch from conduction convection to radiative energy transfer makes choosing the position of the thermocouple to obtain accurate temperature measurements of the sample, which is quite a complicated problem. Next part is the sample preparation. So sample preparation has a significant effect in obtaining good data. It is suggested that maximizing the surface area of the sample in TGA pan, it improves the resolution and reproducibility of the weight loss by the temperatures. The sample weight affects the accuracy of weight loss measurements. Typically, in this TGA instrument, we can use 10 to 20 mg of the sample, okay? And if the sample is volatile, then we use 50 to 100 mg of sample. It is to be noted that most TGA instruments have baseline drift of plus minus 0.025 mg, which is plus minus 0.25 percentage of a 10 mg of sample. So next is the example for of a TGA curve of calcium oxalate. Here you can see this is the TGA curve, calcium oxalate monohydrate. Okay, so the successive plateau corresponds to the formation of anhydrous salt, calcium carbonate and calcium oxide. Here you can see when this is the calcium oxalate monohydrate is heated at a different temperature, there is firstly baseline linear line is obtained. After that there is some weight loss. From that water molecule is removed. Then again it is a constant, and after 340 degrees Celsius it is again there is weight loss. Then calcium carbonate is obtained and carbon monoxide is removed, and again it is linear up to 600 degrees Celsius. Then above 600 degrees Celsius calcium oxide is formed and carbon dioxide is removed. So the thermogram indicates that the loss of water begins at 100 degrees Celsius and loss of carbon monoxide at 450 degrees Celsius and carbon dioxide at 600 degrees Celsius. So these are the steps or reactions which involve in the decomposition of calcium oxalate monohydrate. So there is some factors which affect the TG curve, which include two basic factors such as instrumental factor and sample characteristics. So in instrumental factors, it produces the effect such as furnace heating rate and furnace atmosphere. These are subtypes of factor or sub factors which affect the TG curve. And in sample characteristic, the weight of sample and particle size of sample affect the TG curve. So let us see the one by one. First one is instrumental factor. In that, furnace heating rate, how it affects the TG curve. The temperature at which the compound decomposes depends upon the heating rate. So when the heating rate is high, the decomposition temperature is also high. A heating rate of 3.5 degrees Celsius per minute is usually recommended for reliable and reproducible TG. Second subfactor is furnace atmosphere. So the atmosphere inside the furnace surrounding the sample has a profound effect on the decomposition temperature of the sample. A pure nitrogen gas from a cylinder passes through the furnace, which provides an inert atmosphere. Second factor, main factor is sample characteristics. So there is weight of sample and particle size, how it affects the TG curve. So weight of the sample, a small weight of the sample is recommended. Using a small weight eliminates the existence of a temperature gradient through the sample. And how particle size affect? The particle size of the sample should be small and uniform. It is essential that particle size is small. The use of large particle or crystal may result in an apparent very rapid weight loss during the heating. So these are the two main factors. Now let us see the applications of TGA curve. From TGA, we can determine the purity and thermal stability of both primary and secondary standard, determination of the composition of complex mixture and decomposition of complex. It is also used for the study of sublimation reaction and sublimation behavior of various substances. TGA is used to study the kinetic of the reaction rate constant. It also used in the study of catalyst. The change in the chemical states of the catalyst may be studied by TGA techniques. For example, zinc chromate, it is used as a catalyst for the synthesis of methanol. This technique, TGA method, it is also used for the evaporation of free water begins at a room temperature due to dry gas flowing over the sample. Dehydration, dissolution of bound water always begins at a temperature above room temperature and typically at 125 degrees Celsius. So this method is used for the determination of bound and unbound water which are present in the compound. For example, water present in the suspension of milk of magnesia which is used as a laxative, we can determine the presence of water. Decomposition can have multiple stages, means multiple type of weight losses occur when we apply the heat. So it indicates the presence of multiple components. So by using this TG curve, we can determine the presence of multiple component in the sample. In an overview of thermal analysis testing, it is always preferable to do a TG experiment on unknown sample before doing a DSC experiment, especially for pharmaceuticals, because decomposition of pharmaceuticals renders products which are insoluble and generally sticky on the inside of the DSC cell. These products will lower the life use of the DSC cell. That's why firstly we go for TG experiment and after that we go for DSC experiment. Therefore, knowing of the decomposition temperatures of all drugs, heat in a DSC evaluation should maintain 50 degrees Celsius below to those decomposition temperatures. So this is about the applications. Now next part is the question bank related to the TGA technique. So define some questions are, first one is define thermal analysis and give its type. Explain the principle involved in the TGA with example. Next question is describe instrumentation of TGA. Next, discuss the application of TGA in pharmacy. Name the purge gas used in the TGA system. Give the ideal quantity of sample which is considered to be used in a TGA system. What is meant by thermogram? Explain the TGA curve of calcium oxalate monohydrate. Explain the factors affecting TGA curves. So these are the questions may be useful for your exams and study of thermal analysis. So thank you very much.